The year was 2005. It was late. The glow of a computer screen lit up Linus Torvalds' face. He was staring at lines of code, but he wasn't writing anything new. He was stuck. The tools he used were failing him, again and again. For years, he and thousands of other programmers had been building Linux, the open-source operating system. It was a massive project, a digital cathedral built by a global army of volunteers. But the software they used to manage all their work, a program called BitKeeper, was causing immense frustration. It was like trying to build a skyscraper with tools that kept breaking in their hands. Linus was known for his calm demeanor, but his patience was wearing thin. The old system was not just slow, it was unreliable. It would lose changes or corrupt files. Imagine writing a chapter of a book only to find that the previous chapter has mysteriously vanished. This was the reality for the Linux developers. The very foundation of their collaborative effort was shaky. He knew something had to change, and it had to change fast. The community was on the edge of chaos, their progress stalled by the limitations of a single, flawed piece of software. He leaned back in his chair, the gears in his mind already turning. The problem was fundamental to how they worked. The Linux kernel wasn't built by one person in one room. It was built by a distributed network of brilliant minds, each contributing their own small piece to the gigantic puzzle. They needed a system that could handle thousands of contributions from all corners of the globe. The existing tools were designed for smaller, centralized teams. They treated the code like a precious object locked in a single vault where only one person could access it at a time. This was a bottleneck, a choke point that was slowly strangling the project he had started. He decided he had enough. He couldn't wait for someone else to fix the problem. He would have to do it himself. This was the moment of conception, born not out of a sudden flash of genius, but out of sheer, bone-deep annoyance. Linus Torvalds, the creator of one of the world's most important pieces of software, was about to create another. He didn't set out to change the world of programming. He just wanted a tool that didn't drive him crazy. He needed to build something that worked the way his brain worked. Fast, efficient, and distributed. The revolution was about to begin. To understand the problem Linus faced, you have to understand how software is made. It is not like building a bridge, where you follow a single blueprint from start to finish. It is more like sculpting with clay. You start with a rough shape. You add a piece here, smooth an edge there. You might try an idea, decide you don't like it, and go back to an earlier version. Programmers need to save their work constantly. They need a history of every single change, every addition, and every deletion. This history is called version control, and it is the backbone of modern software development. Now, imagine not one sculptor, but 1,000. They are all working on the same massive statue. One person is working on the hand, another on the face, and a third is fixing a crack in the foot. How do you make sure their work doesn't conflict? How do you combine all their changes into a single, cohesive piece of art without creating a mess? This was the challenge. Old systems, like the one they were using, were clunky. They forced programmers to check out a file, locking it so no one else could work on it. This created endless delays and communication nightmares for a project as large and fast-moving as Linux. The old way was slow and fragile. Sending changes back and forth to a central server took a long time. If that central server went down, everyone's work stopped. It was a single point of failure, a digital Achilles' heel. For a global community that worked around the clock, this was simply unacceptable. Programmers in Australia would be blocked by an issue on a server in California. The flow of creativity was constantly being interrupted. Linus envisioned a system where every single developer had the entire history of the project on their own computer. There would be no central point of failure. This idea was radical. It flipped the old model on its head. Instead of a central hub that everyone had to connect to, Linus imagined a network of proof. Each programmer's computer would be its own server, its own complete repository of the project's history. They could work completely offline, creating new features and fixing bugs. When they were ready, they could easily share their changes with others. This distributed model promised incredible speed and resilience. It was a system designed for a world where collaboration happened across continents and time zones, not just across the hall. With the idea firmly planted in his mind, Linus started to code. He worked with a furious intensity. The entire programming world was watching. He had promised a replacement for BitKeeper in a matter of weeks, a task many thought was impossible. He wasn't just building a tool, he was building the engine for a new way of working. He named it Git, a British slang term for an unpleasant person. It was a joke, a nod to his own self-described difficult personality and his frustration with the state of things. He famously said, "I'm an egotistical bastard, and I name all my projects after myself." First Linux, now Git. The core of Git was its speed. Linus was obsessed with performance. He wanted operations that took minutes in other systems to take less than a second in Git. He designed it from the ground up to be lightning fast. Instead of tracking individual files, Git tracks the content itself. It takes a snapshot of the entire project every time you save your work. This seems counterintuitive, like it would take up a lot of space. But Linus used clever tricks and data compression to make it incredibly efficient. This focus on speed wasn't just a technical detail, it was a philosophical choice. It allowed developers to work at the speed of thought. This new system introduced powerful concepts like branching and merging. Imagine you have an idea for a new feature. With Git, you can create a branch, a separate timeline where you can experiment freely. You can build your new feature, test it, and break things without affecting the main project at all. It's like having a parallel universe for your code. If the idea works out, you can merge your branch back into the main project, seamlessly integrating your changes. If it doesn't, you can simply delete the branch, and it's as if it never happened. This was a game changer for creativity and experimentation. In about 10 days, Linus had a working prototype. It was raw, it was basic, but it was functional, and it was incredibly fast. He had solved his own problem. He had built the tool he needed to continue managing the Linux kernel effectively. But in doing so, he had created something with far greater implications. He had laid the foundation for a revolution in how software was built. What started as a personal project born of frustration was about to be unleashed on the world, changing the digital landscape forever. The speed of Git wasn't just about saving time, it was about unlocking potential. The release of Git in April 2005 was not met with a huge fanfare. It was a tool made by developers for developers. But its impact spread like wildfire through the programming community. People who tried it were stunned by its speed and flexibility. The ability to branch and merge so easily changed how they thought about collaboration. Soon, projects big and small started migrating to Git. It became the de facto standard for open source software. Companies like Google, Microsoft, and Facebook, which once relied on their own internal systems, eventually adopted Git for their massive codebases. Git created a new kind of digital world. It wasn't just a tool, it was a platform for connection. Websites like GitHub and GitLab were built on top of Git. They provided a visual interface and social features that made it even easier for people to collaborate. Suddenly, a lone programmer in their bedroom could contribute to a project being built by a major corporation. A developer in Brazil could fix a bug in a piece of software written by someone in Japan. Git became the universal language for sharing and building code. It was a digital loom weaving together the work of millions of people into a global tapestry of software. This new ecosystem has had a profound impact. It has accelerated the pace of innovation. With Git, ideas can be shared, tested, and integrated faster than ever before. It has made software more reliable, as thousands of eyes can review the code and catch mistakes. It has empowered a new generation of developers, giving them the tools to learn from others and contribute to projects that matter. The software that runs our phones, our cars, and our banks is now built using the principles that Linus embedded into Git: speed, distribution, and trust in the community. It is a testament to the power of open collaboration. Today, Git is an invisible but essential part of our modern world. It is the plumbing of the digital age. It connects millions of developers, enabling them to work together to build the future. It all started with one person, tired and annoyed, sitting at his computer. Linus Torvalds didn't just write a new program, he created a new way for people to connect, to create, and to build better things together. He solved his own problem, and in doing so, he gave the entire world a more powerful way to solve theirs. The legacy of Git is not just in the code it manages, but in the human connections it makes possible.